Okay, clear. Did everybody have that? Sorry, guys. Yes, okay. All right, go ahead and clear. So we're gonna go ahead and get started, guys. Let me go ahead and pass out your beautiful notes for today. They're printed out for you guys. We're not doing much of exploration because we've been doing a lot of construction lately. I want you guys to be able to practice with the problems now, okay? So I'm gonna go ahead and introduce you guys to these theorems, and then we're gonna go ahead and apply them to the given example so that we can go ahead and identify what the steps or the procedures are according to what the theorems say, okay? So let me go ahead and pass out your beautiful notes. Okay, so today's learning objective, guys, is to apply the secant-secant and secant-tangent product theorem. Now, we're gonna go ahead and see both of them because they're very similar to each other, yet different, okay? So I want you guys to be able to identify what similarities they have and what differences they have, okay? So again, secant-secant, secant-tangent. Now, again, like always, I'm going to go ahead and introduce to you guys everything that we should know by now. We know what a chord is, an inscribed angle and a central angle, the relationships, and also what an arc is too. So we have our inscribed quadrilateral theorem. We saw also our beautiful tangent radius theorem. And lastly, we saw, or the latest one that we saw was a chord product theorem. Now, today we're going to be introduced to a beautiful secant. Now, we defined what a secant is, so we know what it looks like. This time, we're going to go ahead and see what relationships it has with other secants. Now, we're going to be focusing on the secant as it intersects another secant or another tangent outside of the beautiful circle. So our first theorem is this one. So secant-secant product theorem, it states that if two secants intersect in the exterior of a circle, so meaning outside, aquí right here in point E, then the product of the lengths of one secant segment, this one, and its external segment, this part, is equal to the product of the lengths of the other secant segment and its external segment. Now, it's a lot of word to like digest in your brain and see or visualize what's happening exactly. But I'm going to go ahead and highlight it for you guys. So what this theorem is stating is that I'm going to go ahead and grab one of the secants, for example, AE, and its exterior part. What's the exterior part? BE. So BE is going to be multiplied by the entire secant. That product, meaning I'm going to go ahead and multiply those two, is going to be equal to the entire secant segment that intersects at point E and multiply that by its exterior part. So in this case, DE. So go ahead and copy this equation right here, guys, so you guys can have it. AE times BE equals CE times DE. If you guys haven't copied it down. If you guys have highlighters, also highlight them so you guys can visualize what we're multiplying with what, okay? And the relationship here. So again, the entire secant segment, AE, times the exterior part, look at that. The entire, not the interior part, the entire secant segment times the exterior part, which is BE. And the same happens with the other segment. So here's my secant times its exterior part. Now those two products, those two multiplications are going to be equal to each other, okay? So we know that they're going to be equal to each other. That's going to be the beautiful pattern that we have here. Equal to each other. And that's how we're going to go and construct our beautiful parts, okay? So again, like these. AE, and then its exterior part. And then CE times its exterior part. Okay. All right. Ready?
Wait, what is it be?
AB. No. It's the entire segment. It's the entire segment and the exterior piece. So at the end, it looks like this, but no. In reality, it's the entire one. Okay? All right, let's go ahead and put this into practice. Okay. So everybody go on to first example. Here it is. Example numero uno. It says right here, find the value of x and the length of each secant segment. So what we're going to do first is that we're going to go ahead and identify each of the parts of our beautiful equation so we can go ahead and identify what the products are and make them equal to each other. So I like to highlight my parts first so I can visualize what's happening. And what we're being asked to do first is to find what AE is. So AE is the entire secant segment. So let me go ahead and do that again because you can't barely see it. So the entire secant segment, AE. Now, what does AE measure? One segment measures 6 and the other one 6. So altogether should be 12. So AE is 6 plus 6, which is beautiful 12. Okay. All right. Now, let's go ahead and identify the exterior part. What's the exterior part? A to D, which is 6. So AD, let me go ahead and highlight that. AD equals 6. Okay. Now, let's go ahead and go on to the next segment, the next secant line. The entire segment is AC. So AC is the exterior part and the interior part. What is it, guys? What is it? Go ahead, Alexandra. What's my exterior part? 5. What's my interior part? X. What do I do to both of them? What operation do I do? Not times. Plus, I'm going to go ahead and add them together. So I should have X plus 5 or 5 plus X. Either way, it's the same, your same term, just written differently. Okay. How do I know? Because I have a 5, I have an X, together makes it 5 plus X or X plus 5. Okay, what's the external part? 5. And the external part is 5. Okay, so let me go ahead and highlight it just so you guys can see it from here to here. Woo, look at that. 5. Let me go ahead and write that down. AB. AB is 5. Okay. Now let's go ahead and set it up. My equation states that I'm going to go ahead and multiply the entire segment, AE. Let me go ahead and write that down. AE times the external part, AD. And it's going to be equal times the entire segment, AC, times the external part, AB. Okay. It doesn't match the theorem equation because the way that the segments are written or identified are different. However, we still have the same idea, okay? So we have the parts. What is AE? AE is 12. Multiplied equals and multiplied. What is AD? 6. What is AC? X plus 5. Notice here that this factor, it has 2 terms. So what do we have to do? We have to put it in parentheses. X plus 5. And what is AB? 5. Okay. Let's go ahead and simplify. 12 times 6. There you go, 72. And then what do we do with the number outside of our parentheses? Distribute. So we should have 5x plus 25. All right, let's go ahead and solve. You have a 2-step equation. Subtract 25. We're left with 72 minus 25. 47 equals 5x. Divide by 5, and we get x equals 47 divided by 9. I mean by 5, 9.4. 9.4. My brain is thinking faster than what I'm trying to say. Okay. All right, 9.4. Now that's the value of x. So x equals 9.4. Now we're asked to find the measurement of each secant segment. So we already found AE. AE is 12. My other secant segment is AC. AC is x plus 5. So therefore, AC is 9.4 plus 5, 14.4. Woo-hoo! Look at that. Not too bad, right? All right. How do you feel about this one? Not too bad? No? Not yet? You guys got this. Okay. Does everybody have this one? Okay. All right. Go ahead and try the next one, guys. Number 2. Let's see if you guys can do this one on your own first. So identify where your secant is, the entire secant, the exterior portion of one segment, and then go ahead and do the same with your other secant and its exterior portion, okay? So do it by parts, separate it if you need to, so you can go ahead and visualize what's happening, and then do your product theorem. No, you can go ahead and pick whichever one you want to first. It doesn't matter which one goes on each side of the equation, guys. They're going to be both equal to each other, so it does not matter. All right. Let me go ahead and clear. Everybody has this? No? Yeah. All right, let me go ahead and give you guys your exit ticket.